Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about signals. So let us start with defining what exactly we mean by signal. The signal is given as a reference to the input when analysis of the circuit or device or the system is to be done. The signal is in voltage or current form. Signals are non-recurrent type. All the signals are time variant and they are not repeating with the time. For example, we have step signal as well as a ramp signal. Both the signals are time variant, they are time dependent and they are not repeating with the time. That is why it is known as a non-recurrent. Then we have waveform. So we'll see what is the difference between signal and waveform. When the signal repeats with respect to time, it is called waveform. They are a recurrent type because they are repeating with the time. For example, we have sine wave and square wave. They are time dependent and recurrent. Then we have spectrum. Normally, in case of a signal or waveform, the magnitude of the signal or the waveform that is dependent on the time. While in case of spectrum, the magnitude of signal is plotted against the frequency. Then it is known as a spectrum. We have frequency on the x-axis and magnitude we have taken on the y-axis. For different frequency, the magnitude of the signal is plotted. Then we have certain test signals. For example, we have step signal and unit step signal, impulse signal and unit impulse signal, ramp signal and unit ramp signal, parabolic signal, sine wave signal, square wave signal, triangular wave signal, Sawtooth wave signal. These are some of the test signals. We'll study each one by one very briefly. First, let us start with a step signal. On the x-axis, we have taken time. On the y-axis, we have taken function of the signal. Now, this is step signal and the magnitude, that is A. Sudden change in the level of the signal from one value to another value, and that is known as a step signal. Normally, the change is from the 0 level to another level. The signal is equal to 0 for t time less than 0, and for time t greater than 0, the magnitude of the signal that is equal to A. In physical system, in case of sudden change, that is indicated with the step signal. Then we have unit step signal. The magnitude of the signal, that is 1. Mathematically, R of t is equal to 0 for time t less than 0, and R of t, that is magnitude of the signal, is equal to 1 for all the time greater than 0. Impulse signal. Again, on the x-axis we have taken time. All the signals are time dependent. A pulse with very small width with magnitude A. Ideally, impulse signal, the value becomes infinite at time t is equal to 0, and the existence of the signal is for very short duration, and for all other time its value is 0. But practically it may not be possible, so we have identified the signal with very small pulse width. Practically a pulse of very small width exists at time t is equal to 0, and the magnitude of the signal is equal to A. Unit impulse signal. The magnitude of the signal is equal to 1. A pulse of very small width exists at time t is equal to 0 with magnitude equal to 1. Mathematically, it can be taken as a delta t, and that is equal to differentiation of u of t, that is function of the signal. Ramp signal, time dependent. On the y-axis we have taken magnitude, and the signal that is increasing linearly with the time. The signal increase linearly from 0 value. R of t is equal to 0 for t time less than 0. For t greater than 0, R of t is equal to A times t, meaning is it increases linearly with the time. Same way, unit ramp signal. The magnitude is equal to 1. The signal increases linearly from 0 value. R of t is equal to 0 for t less than 0. R of t is equal to t for t greater than 0. Value of A is equal to 1. Parabolic signal. The magnitude increase as a square of the time. The value of signal increases as a square of time. For example, R of t, that is equal to A t square by 2 for t greater than 0. R of t is equal to 0 for all values t less than 0. Unit parabolic signal. R of t is equal to t square by 2 for t greater than 0, and R of t is equal to 0 for all time t less than 0. Sine wave signal. We have taken angular frequency. Magnitude is equal to A, that is maximum magnitude. Sine wave is a periodic signal, a recurring signal because it is a time variant, but it repeats with the time. Magnitude of signal varies as the sine of the angular frequency. Square wave signal. Magnitude is equal to A. We have on time and off time, that is indicated as a T1 and T2. In this case, T1 is equal to T2, that is why the square wave is symmetrical type. In certain cases, T1 and T2 may not be equal. For example, here T1 is greater than T2, on time is more and off time of the signal is less, and that is why the signal is known as asymmetrical type. Same way, if on time is less and off time is more, that is actually a duty cycle of the signal. So T1 is less, T2 is more, T1 is less than T2, and that is why the signal is known as asymmetrical type. We have triangular set, maximum magnitude that is equal to A, and we have Sawtooth wave signal. Signal increases linearly and decreases linearly, and maximum magnitude, that is A, time T1, that is the time required to increase the signal from 0 value to a magnitude of A. T1 is very high compared to T2. T2 is the time required for the signal to linearly decrease from 1 magnitude to 0 level. Thank you very much for watching my video. Keep watching. Thank you very much.